All right, the last question on question set 1 is what's the present value of the next coupon payment on the debt? So we have a yield to maturity of 5%, and it's also trading. There's something around here. We have $2.4 billion of market value and the par value. So when it says the market value and the par value, it means that the yield to maturity is also the coupon rate because it's trading at par. So let's just work this out. Okay, there's a bunch of different ways to do this. It doesn't tell us what the face value is, but it doesn't really matter. And I'll work it both ways just so you can see. So let's pretend, because this is what we've been doing in class all semester long. The face value is 1,000. The coupon payment, the coupon rate is 0.05. And so that means the coupon payment on this bond is going to be 1,000 times 0.5 divided by 2 because they are semi-annual. Let me make sure that I got that right. Oh, nope, it's annual. My bad. Okay. We shouldn't need to know anything else. Let's go ahead and calculate what the next coupon payment is. Well, we know it's $50, and the yield to maturity is also 5%. So that means that the effective annual rate would also be 5%. Okay, so there is some information. Oh yes, here it is. A coupon payment on the debt has just been paid. So that means that we don't have another coupon for the year. So that means that we are standing in time 0, and at time 1, we're going to get $50. Well, what's the PV of that? The PV is just going to be $50 divided by 1 plus the yield to maturity to the power of 1. 47.62. If you look at these solutions here, the present value is not just for this one bond, though. It is for the and I have to look back at the number, 2426. 2426, and it's in millions. 1, 2, 3, 1, 2, 3. Number of bonds. Okay, so what we did was we made up a face value. We don't know what the face value of the bonds are. We used the tools that we had at hand to calculate what the payment is in year 1, and then we calculated the PV of that payment. But we know that we have $2.4 billion of bonds outstanding, and if the face value is 1,000, then that means that the number of bonds is 2.4 million. And so that means that in a year, as a company, we're going to have to pay out, let me put commas in here, $121 million. If you get the PV of that, to the power of 1, it is 115 million. And notice, if you want to check yourself, it's the exact same. So there's 2 ways that you could have worked this problem. One is to get the face value of the bond itself, a bond, pick a face value, figure out what the payment is, discount it back to the current day. The other way to do it, let me just copy this so that you can see it. The other way to do it is to say that the face value of all the bonds is that, you know your coupon payment is that, and so you just discount it back to the current day. And we end up, again, with the same thing that we have over here. You can do it either way. The answers will be just the same. This question Doesn't really explicitly say that it should be from the company's perspective, but if you look at the solutions, that's the way it is. But the answer is correct either way, depending on whatever units are in the exam. It's either $47.62 in the case that you have $1,000 face value, or it could be 115 million if you're looking at it from the company's perspective and trying to figure out how much money they'll need on hand to pay for the next coupon payment. Hope that helps.